Hello friends, today we are going to learn basic concepts of fluid mechanics. My name is Professor S.V. Kumbar from Sharath Institute of Technology College of Engineering, Hyderabad. These concepts are related to heat transfer and refrigeration and air conditioning. First important term is fluid. So fluid is a substance which deforms continuously under the action of shear stress. No matter how much shear stress is acting on that substance, it undergoes deformation. Another definition of fluid is it has tendency to flow. In nature, generally, liquids and gases has tendency to flow. So these are considered as fluid. On the basis of viscosity, fluid are classified as ideal fluid and real fluid. Ideal fluid are those fluid which has zero viscosity. Hence, it does not have surface tension and these are incompressible in nature. But in nature, such ideal fluids does not exist. But under some circumstances, we can treat water and air as ideal fluid. Next, real fluid. Real fluid has certain viscosity. That's why it has surface tension as well as compressibility. In nature, all fluids are considered as real fluid. Fluid mechanics. Fluid mechanics is the branch of science which deals with behavior of fluid at rest as well as in motion. Basically, there are three branches of fluid mechanics: fluid statics, fluid kinematics, and fluid dynamics. So first branch is fluid statics. Fluid statics is the branch of fluid mechanics which deals with behavior of fluid at rest. Best example is water stored in a dam or water stored in overhead tank. Second important branch, fluid kinematics. Fluid kinematics is the branch of fluid mechanics which deals with behavior of fluid in motion, but the different forces causing the motion are not considered in this fluid kinematics. Third important branch is fluid dynamics. Fluid dynamics is the branch of fluid mechanics which deals with behavior of fluid in motion, and different forces causing the motion are also considered. Different forces includes pressure force, gravity force, force due to viscosity, force due to compressibility, force due to turbulence, etc. Properties of fluid. First important property of fluid is density or mass density, or it is also known as specific mass. It is the ratio of mass of fluid to volume of fluid. Its SI unit is kg per meter cube. Second important property, specific weight or weight density. Weight density, small w, is the ratio of weight of fluid to volume of fluid. As we know the relationship between weight of fluid and mass of fluid, so weight of fluid is equal to mass of fluid multiplied by acceleration due to gravity. If we substitute this value in the second formula, we will get small w is equal to rho into g, where small w is equal to specific weight, rho is the density multiplied by acceleration due to gravity, that is 9.81 Newton meter per second square. Specific volume. Specific volume is exact reciprocal of mass density. It is a ratio of volume of fluid to mass of fluid. Generally, it is related to gases. Specific gravity. Specific gravity is the ratio of density of fluid to density of standard fluid, or weight density of fluid to weight density of standard fluid. Now one question may be there in your mind, what is standard fluid? So if it is a liquid, water is taken as standard fluid. If it is a gas, air is taken as standard fluid. So as it is a ratio of density of fluid to density of standard fluid, it does not have any dimension. Viscosity. Viscosity is referred to resistance to flow. Whenever any fluid flows, there is always a resistance offered by movement of one layer over another layer. One layer slides over another layer. So that resistance is termed as viscosity. So in the figure, a fixed surface is shown over which any fluid flows. As the surface is fixed, the fluid which is in contact with surface will have zero velocity, and that velocity increases in vertically upward direction. Here two different layers of fluids are shown. One is having u velocity, second is having u plus du velocity. As two equal and opposite forces are acting on fluid layers, then shear stress is induced. This shear stress is directly proportional to rate of change of shear strain, that is du upon dy. Here Newton's law of viscosity states that the shear stress which is produced between two fluid layers is directly proportional to rate of change of shear strain. In order to remove proportionality sign, we have to add proportionality constant. So mu is added, which is known as constant of proportionality or coefficient of dynamic viscosity. So dynamic viscosity mu can be written as tau upon du upon dy. So we can define dynamic viscosity in this manner: the amount of shear stress required to produce unit rate of shear strain. Generally, dynamic viscosity is measured in a Newton second per meter square, that is SI unit. We can also measure dynamic viscosity in poise also. Poise is CGS unit of dynamic viscosity. So there is a relationship between SI unit and CGS unit, that is 1 Newton second per meter square is equal to 10 poise. Second viscosity, that is kinematic viscosity, it is a ratio of dynamic viscosity to density of fluid. So dynamic viscosity is substituted in Newton second per meter square and density in kg per meter cube. The unit of kinematic viscosity will be meter square per second. If any fluid obey Newton law of viscosity, it is referred as Newtonian fluid, and if any fluid does not obey Newton's law of viscosity, it is known as non-Newtonian fluid. Properties of fluid. So here variation of viscosity with temperature is shown. As temperature of liquid increases, its viscosity decreases. As temperature of gases increases, its viscosity increases. Why does it happen? There are two important things. First one, cohesive force. Second one, molecular momentum transfer. Cohesive force is the force of attraction between same molecules of same fluid. So in case of liquid, as temperature increases, the bond between two molecules breaks. Hence, as the temperature increases, cohesive force decreases, hence viscosity decreases. Molecular momentum transfer. Already all the molecules are in constant motion. When one molecule collides with another, molecular momentum exchange takes place. In case of gases, as the temperature increases, molecular momentum transfer rate increases, hence its viscosity increases. So here in this slide, the relationship between viscosity and temperature is shown. For liquids, mu is equal to mu naught into bracket 1 plus alpha t plus beta t square. For gases, mu is equal to mu naught plus alpha t minus beta t square, where mu naught is the viscosity at absolute 0 degrees centigrade, alpha and beta these are the constant values, T is the temperature at which viscosity is to be measured. Next, types of fluids. Already we have seen two types of fluid, Newtonian fluid and non-Newtonian fluid. Newtonian fluid are those fluid which obeys Newton's law of viscosity, hence there is a linear relationship between shear stress and rate of shear strain. Non-Newtonian fluid in which shear stress is not proportional to shear strain. Binigum plastic fluid resists a small shear stress but flow easily under the large shear stress. For example, sewage sludge, toothpaste and jellies. Pseudoplastic fluid are the most non-Newtonian fluid in which viscosity decreases with increasing velocity gradient. For example, colloidal substances like clay, milk, etc. Dilatant fluid, viscosity decreases with increasing velocity gradient. For example, quicksand, thixotropic fluid in which there is a non-linear relationship between shear stress and rate of angular deformation beyond its initial yield stress. These are the some thermodynamic properties of any fluid. PV is equal to MRT, where P is the pressure, V is the volume, M is the mass of fluid, R is the universal gas constant, and T is the temperature at which all the properties are calculated. Compressibility. Compressibility is the reciprocal of bulk modulus. What is bulk modulus? It is a ratio of compressive stress upon volumetric strain. If you consider one example in which a gas is enclosed in piston and cylinder arrangement. If you apply force, what will happen? Gas will compress. Here pressure will increase but volume will get decrease. So bulk modulus is equal to compressive stress upon volumetric strain, which is equal to dP upon minus dV into V, where negative sign shows there is a decrease in volume. Surface tension. Surface tension is defined as the surface tensile force acting on the surface of liquid which is in contact with gas, or on the surface of two immiscible liquid, so that this surface acts as a stretched membrane under tension. The best example of surface tension is a small spider like insect can walk easily on the water surface. Few more example: spherical shape of water, it is because of surface tension. Hollow bubble, the shape of hollow bubble retains unless and until the pressure P is equal to 8 sigma upon D. This is also because of surface tension. And liquid jet, which is coming through nozzle. The unit of surface tension is Newton per meter. Capillarity, the phenomenon of rise or fall of liquid with respect to its initial level when a small diameter glass tube, which is known as capillary tube, is immersed vertically in liquid is known as capillarity. If there is a rise of liquid level in capillary tube, it is known as capillary rise. If there is a fall of liquid level, then it is known as capillary fall or capillary depression. So this capillarity H can be calculated by the formula 4 sigma cos theta upon rho GD, where sigma is surface tension of that fluid, G is density, rho is density, G is acceleration due to gravity, and D is the diameter of capillary tube. Vapor pressure. When any fluid is heated, then the molecules of vapor will start escaping from the free surface of liquid. This happens in case number 1. But when the same fluid is heated in a closed container, what will happen? The molecules of vapor will be collected on the region above the free surface of liquid. So the partial pressure exerted by this vapor on the free surface of liquid is known as vapor pressure. So this vapor pressure concept is very important in pumps and turbines, especially reaction turbine. When the pressure of any fluid falls below vapor pressure, then boiling of that liquid starts and bubbles are formed. When these bubbles falls on metallic surface, causes pitting action or cavity. This concept is known as cavitation. Pressure. Pressure is defined as force on unit area, force acting on unit area. So P is equal to F upon A. If you want to calculate pressure force, so F is equal to P into A, that is pressure into area. Generally, pressure is measured in Newton per meter square in its SI unit, but pressure can be also expressed in Pascal, kilopascal, bar, PSI, Newton per centimeter square, kg force per centimeter square, etc. Pascal's law. Pascal's law states that the pressure or intensity of pressure at a point in a static fluid is equal in all directions. The best application of Pascal's law is hydraulic braking system. Unless and until driver applies the brake, fluid is in a state of rest. But as soon as driver applies brake, that force will be applied equally to all wheel. Hence vehicle stop in quick distance and quick time. So in Pascal's law, Px is equal to Py is equal to Pz. So pressure remains same in all direction when fluid is in a state of rest. Hydrostatic law of pressure, it states that the rate of increase of pressure in vertically downward direction is equal to the weight density of fluid at that point. One fluid element is shown. Three different forces are acting on that fluid element: pressure force on face AB, pressure force on face CD, and weight of that fluid element. If you do summation of all vertical forces is equal to 0, you will get dou P upon dou Z is equal to rho G. So this hydrostatic law of pressure is used to determine pressure at any point in liquid. Next, relationship between pressure. So here, first of all, we need to learn absolute zero pressure. Absolute zero pressure is defined as pressure of complete vacuum. Now, if you want to measure absolute pressure, absolute zero pressure is taken as standard reference surface or datum surface. Pressure is measured above zero pressure, then it is known as absolute pressure. So a red colored arrow which is shown here is nothing but absolute pressure. In gauge pressure, atmospheric pressure or barometric pressure is taken as datum surface. So green colored arrows are shown for gauge pressure. Vacuum pressure is nothing but negative gauge pressure. Measurement of pressure. Pressures are measured with the help of different measuring instruments. First, manometers. Second, mechanical gauges. Manometers are classified as simple manometers, differential manometers. Simple manometers are classified as piezometer, U-tube manometer, single column manometer, whereas differential manometers are classified as U-tube manometer, inverted U-tube differential manometer. Mechanical gauges are classified as diaphragm pressure gauge, Bourdon tube pressure gauge, deadweight pressure gauge, bellow pressure gauge. We will see construction and working of each pressure measuring devices in the next video lecture. Thank you very much.